Hi, this is Michail Beliatis. This is a early feasibility study about digital product passport as a carrier for information of life cycle assessment for composite materials is as part of the Composite Circle Interact project. The project aims to coordinate industry effort, adopt digital infrastructure and sustainable recovery methods to enable the recycling of fiber reinforced polymer composite across borders, reducing the environmental impact. So a bit about more the project. Digital product passport EU definition is a product-specific dataset which electronically can be accessed through a data carrier to electronically register process and product-related information among the value chain of involved stakeholders. Therefore, the primary objective of the project is to establish a synchronized transaction value chain for the circularity of fiber-reinforced composite products as part of the EU Eco-Design for Sustainable Product Regulation, which is enforced 2024. To do that, the transactional approach is essential, pooling industry capabilities across the Baltic Sea region to create economical viable recycling infrastructure. Actors across the wind turbine value chain will be mobilized, existing recycling and digital infrastructure will be adopted, and activities within circular loops will be coordinated. Key activities such as on-site automatic sorting, logistics, storage, material digital traceability with a digital product passport, and pre-treatment of waste to prepare it for recycling and Solvolysis will be demonstrated as feasibility for circularity of composite materials. And with that, I would like to pass the word to my colleague Christina, which will explain more the findings of the study.
Hello, so for me, my name is Christina Tsitsiva, and today I'm gonna present you the paper with title Digital Product Passport as Digital Carrier for Information of Lifecycle Assessment and Feasibility Study of Solvolysis on Composite Material for Wind Turbines Plates. So basically, this study dives deep into a key technology that is basically the digital passport that can provide the framework that is needed to track and manage those complex materials throughout their life cycle. So let's put the challenge into perspective. The average lifespan of a wind turbine is about 20 to 25 years. Over the next decade, so it was forecasting that it's gonna be 325 kilotons of end-of-life blades that will need to be dealt with. Currently, the most common solution is landfilling, which is clearly unsustainable. It causes environmental pollution and also starts to create an economic burden. So that's why we have a strong need for a circular economy solution that focuses on recovering valuable resources and minimize waste. So in order to do that, we have a few recycling methods available, and one is the mechanical recycling, which involves shredding the blades into smaller pieces, but it's less energy intensive and it has already an existing infrastructure, which makes economically viable, but the recovered materials have limited uses. So it's a short-term solution. Moving to the thermal one, we're using high temperatures to bring down the materials, which produces gases and oils. However, it requires a lot of energy and it's not that economically viable. And as a third option, we have the chemical recycling. More specifically, now we're going to talk about solvolysis, where basically we use the solvents to break down the components, which allows to recover high quality materials. While it's more complicated and requires initial energy consumption and a new infrastructure, it is a key part of our long-term solution. So fortunately, European legislation is moving in the right direction to support these efforts. So we have the European Waste Framework Directive and the Circular Economy Action Plan that are engaging on the recycling of complex components. concept like extended producer responsibility that promotes sustainable products and placing the responsibility on manufacturers, and also the digital product passport, which is a core part of our paper and is a key tool in this framework, as it brings crucial transparency to the entire product lifecycle. So to truly understand the impact of our recycling efforts, we use lifecycle assessment, which is a decision-making tool that follows ISO standards, involves 4 main stages: defining the goal, the scope, creating an inventory analysis of inputs and outputs, assessing the environmental impact, and interpreting the results. This systematic approach allows us to compare different methods and make informed decisions. So this diagram illustrates the value chain and the fact that we had the original materials we got from the digital passport of the manufacturer, wind turbine manufacturer, and it's based on only one blade that it was decommissioned, sent to the shredding facility to be shredded to a specific dimensions, and then transported again to the chemical facility, where basically we input the blades pieces into an autoclave along with the catalyst and the solvent, and leave it for almost a week. And based on the information that we gathered from the literature, we were able to show the following results. So before going to the environmental impact through the OpenLCA software that was used for this research, you can get this kind of Sankey diagram. While it's a complex visually represents the material flow within the treated blade process. The thickness of the lines basically indicates the volume of materials and energy at its states from upstream production to the final recycling output. So it can provide a detailed look and the inputs and outputs, helping us quantify the overall efficiency of the Solvolysis process. And now to our results of environmental impact assessment. As you can see, while we're comparing the traditional landfill scenario to the chemical processed blade, the treated blade process showed a clear advantage across a wide range of environmental indicators. For example, it reduces the climate change impacts from fossil fuels and also other categories, and this provides a strong evidence for the environmental benefits of adopting this recycling method over landfilling. So beyond the environmental benefits, there's also a compelling business case for Solvolysis. While the initial investment for infrastructure might be high, the process has a strong long-term economic case. By transforming basically the waste into valuable recoverable materials, companies can basically generate new revenue streams. So also they can avoid the significant cost from the landfill disposal. So it's necessary to do some future pilots, and that's basically it's gonna be achieved from the project that Michael talked about in order to validate the profitability and address any remaining technical challenges. But in general, the outlook is very positive. So in order to make all this work, we need a collaborative network that is driven by sustainability and powered by data. So this is where the digital product passport comes in. The DPP actually acts as a digital carrier for the information needed throughout the product's lifecycle. So it links together all key stakeholders from material suppliers, wind turbine manufacturers to recycling operators and transportation providers, ensuring transparency, enabling seamless data exchange. This digital framework has the potential to optimize basically the end of life decisions of the wind turbines. So implementing the product passport requires a phased approach. Basically, phase one is to lay the foundation, focusing on establishing the data governance architecture and fostering collaboration among all stakeholders. This ensures the data ownership, security, and interoperability. While phase two will involve the pilot testing, the functionality in real-world settings to work out any issues. And finally, on phase three, we have the system integration, connecting the DPP with existing enterprise systems to fully operate the process. So in conclusion, the path to a circular economy for wind turbine blades is clear. Solvolysis offers a significant environmental benefit by reducing waste and emissions and outperforming traditional landfill disposal. It can be also economically feasible in the long term, with the revenue from the recovered materials offsetting the initial costs. And the digital product passport is a crucial enabling technology that will provide the data and transparency needed for success. So thank you very much from my end for listening to my presentation, and hopefully will contact us for any further questions. Thank you very much.